3.4 Orbits in the Solar System. Learning Objectives. By the end of this section, you will be able to compare the orbital characteristics of the planets in the solar system. Compare the orbital characteristics of asteroids and comets in the solar system. Recall that the path of an object under the influence of gravity through space is called its orbit, whether that object is a spacecraft, planet, star, or galaxy. An orbit, once determined, allows the future positions of the object to be calculated. 2 points in any orbit in our solar system have been given special names. The place where the planet is closest to the Sun, Helios in Greek, and moves the fastest is called the perihelion of its orbit. And the place where it is farthest away and moves the most slowly is called the aphelion. For the Moon, or a satellite orbiting Earth, G in Greek, the corresponding terms are perigee and apogee. In this book, we use the word moon for a natural object that goes around a planet, and the word satellite to mean a human-made object that revolves around a planet. Orbits of the planets. Today, Newton's work enables us to calculate and predict the orbits of the planets with marvelous precision. We know 8 planets, beginning with Mercury closest to the Sun and extending outward to Neptune. The average orbital data for the planets are summarized in Table 3.2. Ceres is the largest of the asteroids, now considered a dwarf planet. According to Kepler's laws, Mercury must have the shortest orbital period, 88 Earth days. Thus, it has the highest orbital speed, averaging 48 kilometers per second. At the opposite extreme, Neptune has a period of 165 years and an average orbital speed of just 5 kilometers per second. All the planets have orbits of rather low eccentricity. The most eccentric orbit is that of Mercury, 0.21. The rest have eccentricities smaller than 0.1. It is fortunate that among the rest, Mars has an eccentricity greater than that of many of the other planets. Otherwise, the pre-telescopic observations of perigee would not have been sufficient for Kepler to deduce that its orbit had the shape of an ellipse rather than a circle. The planetary orbits are also confined close to a common plane, which is near the plane of Earth's orbit, called the ecliptic. The strange orbit of the dwarf planet Pluto is inclined about 17 degrees to the ecliptic, and that of the dwarf planet Eris, orbiting even farther away from the Sun than Pluto, by 44 degrees. But all the major planets lie within 10 degrees of the common plane of the solar system. Link to learning. You can use an orbital simulator to design your own mini solar system with up to 4 bodies, adjust masses, velocities, and positions of the planets, and see what happens to their orbits as a result. Orbits of asteroids and comets. In addition to the 8 planets, there are many smaller objects in the solar system. Some of these are moons, natural satellites, that orbit all the planets except Mercury and Venus. In addition, there are 2 classes of smaller objects in heliocentric orbits, asteroids and comets. Both asteroids and comets are believed to be small chunks of material left over from the formation process of the solar system. In general, asteroids have orbits with smaller semi-major axes than do most comets. The majority of them lie between 2.2 and 3.3 AU, in the region known as the asteroid belt. As you can see in Table 3.2, the asteroid belt, represented by its largest member, Ceres, is in the middle of a gap between the orbits of Mars and Jupiter. It is because these 2 planets are so far apart that stable orbits of small bodies can exist in the region between them. Comets generally have orbits of larger size and greater eccentricity than those of the asteroids. Typically, the eccentricity of their orbits is 0.8 or higher. According to Kepler's second law, therefore, they spend most of their time far from the Sun, moving very slowly. As they approach perihelion, the comets speed up and whip through the inner parts of their orbits more rapidly.